In this video, we'll introduce, show a few examples of, and work through the proof of the product rule for derivatives. The product rule states that if f of x and g of x are differentiable functions, then the function f times g of x, which is just another notation meaning f of x times g of x, is a differentiable function, and the derivative of f times g of x is equal to the derivative of f of x times g of x plus f of x times the derivative of g of x. Let's first show an example that we can verify using the power rule, sum rule, and constant multiple rule of derivatives. Let's suppose that h of x equals 2x to the fourth times 3x plus 9, and we need to find the derivative of h of x. Let's first use the product rule. Let f of x equal 2x to the fourth and g of x equal 3x plus 9. Then by the power rule, f prime of x equals 8x cubed and g prime of x equals 3. Then by the product rule, h prime of x equals 8x cubed times 3x plus 9 plus 2x to the fourth times 3. Distributing this and grouping the like terms gives us 30x to the fourth times 72x cubed. And just to verify, not that it proves anything, let's try to find the derivative of h of x by expanding and using the power and sum rule. So we start with 2x to the fourth times 3x plus 9, and expand that by distributing 2x to the fourth over 3x and 9, giving us 6x to the fifth times 18x to the fourth. The derivative h prime of x is then 30x to the fourth plus 72x cubed, which is what we got using the product rule. Let's do one more example before we look at the proof. Say f of x equals 5 times the square root of x, and g of x equals 8x squared plus 1, and we want to find the derivative of h of x, where h of x equals f of x times g of x. Let's again compute f prime of x and g prime of x. 5 times the square root of x is 5x to the 1/2 power, so the derivative f prime of x is 1/2 times 5x to the minus 1/2, or 5/2 x to the minus 1/2. The derivative of g of x can be found using the power rule and sum rule of derivatives, and turns out to be 16x. So using the product rule that the derivative of f of x times g of x is the derivative of f of x times g of x plus f of x times the derivative of g of x, we get that the derivative of h of x is 100x to the 3/2 plus 5/2 x to the minus 1/2. If we instead simplify h of x by distributing the 5x to the 1/2 over the 8x squared plus 1, and then take the derivative of 40x to the 5/2 plus 5x to the 1/2, we get h prime of x equals 100x to the 3/2 plus 5/2 x to the minus 1/2, which is the same answer using the product rule gave us. So we've seen it in use a few times now. Now let's prove that it always works, provided that f of x and g of x are differentiable. Now let's prove that given differentiable functions f of x and g of x, the derivative of the product of f of x and g of x is equal to the derivative of f of x times g of x plus f of x times the derivative of g of x. Let's first write what the expression of the derivative of f of x times g of x looks like using the definition of the derivative. If we consider f of x times g of x as a function and apply the definition of the derivative, namely applying x plus h as its input and then subtracting from it the function with x as its input and dividing by h and taking the limit as h approaches 0, we get this. Now, let's cut to what we say we're setting out to prove this is equal to. This is what the derivative of f of x times g of x plus f of x times the derivative of g of x looks like using the definition of the derivative. Let's work backwards instead of forwards and if we can get this to look like the expression from the previous page, we can consider it proven. First of all, with this, we can rewrite g of x as the limit as h approaches 0 of g of x, since g of x is g of x no matter what h is, since h is not a part of g of x. And likewise, we can write f of x as the limit as h approaches 0 of f of x, so we get this as the expression on the bottom. Now the product law of limits tells us that if the same limiting variable is approaching the same limit, the product of two limits is the limit of the product. So we can combine the limit as h approaches 0 of f of x plus h minus f of x over h and the limit as h approaches 0 of g of x into the limit as h approaches 0 of f of x plus h minus f of x over h times g of x, and likewise for the right term, giving us the expression on the bottom. Now we can distribute g of x over f of x plus h minus f of x on the left term, and f of x over g of x plus h minus g of x on the right term, giving the expression on the bottom. And now we can use the sum law of limits, which says that if the two limits have the same variable approaching the same limit, the sum of the two limits is the limit of the sum, which gives us the expression on the bottom. And then, of course, we can combine these two quotients since they share the same denominator. So here's where we're at. The expression on the top is what we've gotten so far using limit laws and algebraic manipulations, and we want to work back and reach the expression for the derivative of f of x times g of x using the definition of the derivative, which is the expression on the bottom. So how can we convert the expression on the top to the expression on the bottom? Let's draw these four terms, f of x plus h, g of x, and g of x plus h, as the lengths of the sides of a rectangle, as shown here. Then the areas of the four quadrants are as shown. Now, as we take the limit as h approaches 0, f of x plus h approaches f of x, and g of x plus h approaches g of x, so that the height becomes nearly divided into two equal lengths, and the width becomes nearly divided into two equal lengths, so that this rectangle gets divided into a diagonal pair of equal areas. If the diagonal areas are equal to each other as we take the limit as h approaches 0, then the area of two diagonal rectangles is equal to the area of the other two diagonal rectangles, and the area of two of the diagonal rectangles minus the area of one of the other diagonal rectangles is equal to the remaining rectangle, so that we can say, as h approaches 0, the area of f of x plus h times g of x plus f of x times g of x plus h minus f of x times g of x becomes equal to f of x plus h times g of x plus h. So we showed that the derivative of f of x times g of x plus f of x times the derivative of g of x is equal to the derivative of f of x times g of x, which is what we set out to show.